Welcome to my channel Pharmacopoeia. This is your RK.
This is my first section. In this section, I will tell about how to set the parameters of A.W.C auto weight controller or CFC compaction force controller in compression machine. Few persons ask what is the difference between the A.W.C and CFC. That's a foolish question in my thoughts because both principles are the same for controlling the tablet weight and both works on forces only. First of all, we should know about the tablet compression machine. A tablet compression machine is a mechanical device that compresses the powder into the tablets of uniform size and weight. A tablet compression machine can be used to manufacture tablets of a wide variety of the materials, including pharmaceuticals, nutraceuticals, cleaning products, and industrial pellets and cosmetics. To form a tablet, the granulated powder material must be metered into a cavity formed by the two punches and a die, and then the punches must be pressed together in a great force to fuse the material together. How to control the compression forces? A tablet press can be instrumented with a strain gauge that senses and reacts to compression forces changes. Compression force fluctuation is the result of slight changes in tablet weight, and it is a normal unexpected that powder blends are not perfectly uniform. This fluctuation is detected by checking the tablet weight during the compression. When tablet weight changes, they typically trend either increasing or decreasing in average tablet weight. As tablet weight increases, the compression force increases, and as tablet weight decreases, the compression force decreases. As blended powders are being compressed, there is a constant and measurable process rhythm that is detected using a strain gauge. A strain gauge sends signals to control the volumetric powder filling level, that is the weight adjustment cam or dosing cam or metering cam, which controls the tablet weight. Thus, we have created a loop. The amount of force to compress is really reporting tablet weight. The controls can be set up to react the compression force changes and adjust the weight within a range or stop the press if the amount of force is too much or not enough. This is directly attributable to tablet weight provided that the press is being operated correctly and all parts and components are in good operating condition. How to set the A.W.C parameters? A.W.C works on the principle of compression forces. In the first, we set the target fill weight and run the machine, acquire the reference value of the force and the set parameter. Set the machine on lower fill weight against the standard limit of the procedure and observe the average compression force. Similarly, set the machine for higher filling weight and observe the average compression force. Now feed the value of the lower and higher compression forces and observe above. First, suppose I take the parameter limits be like that is the standard limits. Weight of the tablet is 972,030 mg and thickness is 6.20 mm to 6.80 mm. Hardness is 90 to 170 kp. Set the all parameters in compression machine like filling depth and thickness and run the machine and I get the values like weight of the tablet is 995 mg to 1005 mg. Thickness of the tablet is 6.50 mm to 6.57 mm. Hardness of the tablet is 125 kp to 130 kp. Note down the all force average value from the machine. Let it be like 8.20 mm is the filling depth, 3.00 mm is the thickness, and 27 kp is the force average value. Now we set the lower compression forces, then we go to the lower values while reducing the tablet weight up to the lower limit, that is the 975 mg to 985 mg, and don't change the thickness value, that is a we got the previous value in the optimum parameters like 6.50 to 6.57. Don't change that value, then run the machine. We got the lower force average value, let it be like 19 kp. Take the percentage of the optimum force value 27 kp and its lower force value is a 19 kp and its percentage is 30%. And now set the high compression forces. Then we go to the higher values while increasing the tablet weight up to the higher limit, that is the 1015 mg to 1025 mg, and don't change the thickness value, that is the 6.50 mm to 6.57 mm. Then run the machine and we got the higher force average value, so let it be like a 35 kp. Take the percentage of the mean average value 27 kp and its a higher compression force average value 35 kp and its a percentage of 30%. Finally, we get the optimum force average value 27 kp and lower compression force average value 19 kp and higher compression force average value 35 kp. Set the values like HEP high ejection pressure and LEP lower ejection pressure and it's like a 30% of both. Machine will eject the tablet when forces cross the set limit. Set the machine stop limits like 35 to 40% HSP higher stop pressure and LSP lower stop pressure up to our consideration. The reference of optimum force average value. When the mean or average value beyond the set limit, the machine will be stopped and we give the filling control of calculated the force average value in every 3 rotations of the disc or turret. Set the how much filling is to be taken. Take 1% or 1.5% or 2% of the force average value. It's up to our considerations. Standard deviation is main parameter in A.W.C. Standard deviation is to set the limits for particular punch force. Take the minimum force value of individual punch force when the tablet in lower weight. Take the maximum force value of individual punch force when the tablet in higher weight. The difference between the minimum or maximum force value to optimum force average value. Individual punch forces values like 17 kp is a lower and 37 kp is a higher. It is a 27 kp is the optimum force value and difference is a 10. So standard deviation is a 10%. When the individual punch forces values beyond the standard deviation set limit, the machine will be stopped. If you like this video, please like, share and subscribe my channel Pharmacopoeia.